Okay, we're now recording. Basically, I planned these sessions if anybody has any problems you want to see worked. So is there any problems out of the book anybody would like to see? I think I've got a system I can kind of show you out step by step.
There was one problem that where we had to find the area of a trapezoid on the coordinate plane.
Okay, can you point?
So,
I've got the book.
Oh, it wasn't in the
problem.
It was on like the practice quiz thing.
Oh, it was on the practice quiz?
Yeah. So
don't have that in front of me. I don't remember doing areas of trapezoids. We did areas of triangles. Do you happen to have the dimensions of the triangle in front of you?
Let me see if I can find it. I was just on it.
Do you happen to have the dimensions?
I'm pulling up the practice quiz right now. Let's see. Okay. Yeah, so it was like 4 different dimensions, and it was I think it was a trapezoid, yeah. And that,
okay.
Yeah. So, do you want me to give you the 4 dimensions that it gave me? Or the
yeah,
4? It was the 4 coordinates.
Oh, there was 4 coordinates?
Yes. Yeah.
Is this off WebAssign?
Yes, it is.
Okay. Yeah, can you feed me the 4 coordinates?
Yeah. Okay. Hold on just a second. My screen just went away.
2.5 seconds.
Sure.
Okay, so the coordinates it gave me were the first one was 3, 0.
Okay.
And then the second one was 9, 0.
All right.
And then the third one was 8, 7. And then the last one was 4, 7.
4, 7.
Yeah.
Okay. Here's one going to do that.
Okay, I'm trying to draw a picture. We got a big screen here. I'm trying to. Okay, here we are.
I'm running to go get the
Okay, he's my at-home assistant is running to get the cord because we got a power low signal on this. Let me see if I can y'all see the screen and me drawing on this? You can't. Okay, good. I'm actually using my iPhone as the camera. I've got it set up here using my iPhone as the camera, and this is a lot more comfortable on me drawing a tablet was. All right, let me see if I can, you got to point at 30, point at 90, a little bit of a delay, okay, point at 8 and 7, so you're over 8 and up 7. Let's see, all of a sudden it's not tracking where I think it should. This was working much better in the one. Okay, 3, 4, 5, 6, 7. Over 8 and up 7. We'll label that 8 and 7. This one's 9 and 0. This one's 3 and 0. So now I need over 4 and up 7. 4 and up 7. Okay, so I see a trapezoid. All right. Can you all see this? Is this as clear as linear?
Yeah.
Okay. There's actually several ways to do that, or in fact, I can think of 2 ways. There is a trapezoid formula. It kind of depends on if you remember what that formula is, and you can plug and chug. I'll show you that. I don't know if this will ring a bell or not. If it doesn't, I'll show you method 2. there is 1/2 times h times b1 plus b2. Okay, the b1 and the b2 are these bases here, the lengths of them. The h is this vertical distance. Thank you very much, Sterling. Okay, now it looks like the B1 is the difference between 9 and 3, so that seemed to be 6. The B2 is between 8 and 4, so that would be 4. And your H is this vertical height, looks like it'd be 7. So we can plug and chug those numbers and get 1/2 times 7 times 6 add 4. H being 7, B1 being 6, B2 being 4. And so you get 1/2 times the 7, 6 plus 4 is 10. You can go 70 over 2, getting 35. Or 1/2 of 10 is 5 times 7 is 35, however you want to play it. Now, this method doesn't work real well if you don't remember the formula or you've never seen it before. So what shape, because there is another way to do it. It's longer, but it uses rectangles and triangles. So are you interested in that method? Or is this the only method you need?
I mean, are we also gonna have to do area of triangles as well? I feel like it might be good practice.
To see it?
Yeah.
Yeah, because what you can do, if you want to call this, by dropping that vertical, I made triangle 1, drop a vertical here, you've made triangle 2, and then you got a rectangle in the middle. Call that 3 maybe. So you can bust it up into 2 triangles with a rectangle, and then do them as 3 small areas, add them up. And if we don't get 35, I'm going to resign on the spot and go get my dream job. Walmart greeter.
No.
Almost there. Okay, do you want to see it done that way? Okay, we'll see if this works. It should. So method 2, you've got, let's see, we'll call it triangle 1, add triangle number 2, add rectangle number 3. Now a triangle is 1/2 times base times height, and this 1/2 times base times height, and then the rectangle is length times width. Hope you remember, a simple triangle is 1/2 times the base times the height. The base is the small area, the height is still vertical there, and you got 1/2 of it. All right, so plugging and chugging these numbers. 1/2. Looks like the base is 1. You can see it there. And their height is 7. And you got the same thing on triangle 2. 1 on the base, height is 7, times 1 times 7. And in the middle, looks like your rectangle, that would be 4, and that would be 8. So it looks like you've got a length of 4, or you call that a width. I mean, it doesn't matter which one's the length, which one's the width. And I have frozen.
Let me figure out your.
Okay, oops, and I lost my big sheet. Oh, we're back. Thank you to my technical assistant.
Okay, let me see if I can center this well though.
Okay, all right.
Is that okay?
Yeah, that's fine.
Okay, then continue your teaching.
Okay. And then all right, so one dimension is 4, I think. Yeah, 8 minus 4 is 4. And then the height on it is 7. All right, so it looks kind of completely different. But let's see if we can get it to work. You can either do 7/2 here and combine with 7/2. Or you can play it, if you want to do 7 halves, it's 3.5, which is 3.5. You can go to decimal real quick if that's easier on you. And you get another 3.5, 3.5 from 7 halves. And then 4 times 7 is 28. 3.5 is 7. Gosh golly gee.
What's wrong?
There it is. 7 plus 28, 35. So yeah, it's longer, but it does have maybe more familiar pieces. Or you can do it shorter if you can remember this formula. Okay, does anybody have any question about this one or want anything else worked out? I see Miss Megan Smith, Miss Angela Torres, Miss Jay Rain, Miss Leanne Danley. There may be other people. I don't see the button to see more people. Does anybody have any?
Could you do one of the symmetry questions?
Okay, is this out of the book?
Yes, sir.
Can you point to one?
Yes, sir. It's like testing an equation for symmetry. So test the equation y equals x cubed minus 9x.
Y equals x cubed minus 9x for symmetry.
Yes, sir.
Okay. Yeah, there's several ways to do this. Basically, I'll how to explain it really quick. There's really two kinds of symmetry. Y-axis symmetry. All right, the simplest function that does that is x squared. So if I plug in x is, say, 1, I get 1. And if I plug in -1, I also get 1. So if I generalize this to an x, then this is an f of x. When I have -1, that's a minus x. And I go up and I get f of minus x. So the idea is f of x equal to f of minus x, using a function notation. If this is true, I have y-axis symmetry. So basically what happens is the original f of x is what's given. And I'm going to plug in minus x. And if nothing changes, I have this y-axis symmetry. So I'm going to plug in minus x. So I get f of minus x to the third minus 9 times minus x. Well, a negative to an odd power stays negative. Negative x to the third, and -9 times -x to positive 9x. Okay, so this clearly is different from the original. So it does not have y-axis symmetry. This case does not work. So the second case of symmetry is called origin symmetry. The graph kind of looks like this. It goes through the it's either up on the right and down on the left, or vice versa. You could actually do this. So what happens is I'll do it with x's and then an f of x. Same distance, but it's minus x. And you come down to f of minus x. Well, these are the same distance, but they're negatives of each other. Negative f of -x. In plain English, that means the term switch sign. Is this a negative of what you had? You don't really have to test anything more. You can see, you see how you started with positive x cubed, you went to negative, and you had a negative term here, turned positive. That's exactly what this is saying. Your formula wind up the negative of what you had originally. So this is a case of origin symmetry. Answer, origin symmetry. And I lost my
Let
phone.
me fix it.
Phone screen go, there we are, but yeah, there we are, okay. Does that help, or was that like Chinese?
That helped. Thank you.
Okay. Let me, is there any other questions out of the book? Because I'd like to pull up one myself and see. I consider these problems very simple, but I've taught college algebra for years, and problems like this, for some reason, just baffle people. Can I ask if anybody had any trouble with problems like this? It's right off the first section. We got 15 minutes left. Let's see. Yeah, it's on page 92. I'll just pick something like 17. Graph. And they give you some gibberish notation here. X, Y. Give you a line, X greater than or equal to 1, and the Y is less than 3. Now, personally, I consider that an extremely simple problem, but it does have a lot of gibberish in it. And I have met people that go, whoa, whoa. So would you all be capable of this incredibly simple problem, or would you need an example of something like this?
I would need an example.
Yeah.
You would?
Give me an example,
Please.
please.
Well, could we use this one?
Yeah.
My goodness, so polite. Yes, of course. Okay. I tried to put this in the files in D2L, but I understand it's hard to read without somebody showing you and explaining it. But it works off your basic graphs. So let me try to build up to it. If I had you graph x equals 1, does everybody know this is a vertical line? And would look like, here's one, well, maybe I'll put it to the side. This, that's supposed to be vertical. Does everybody know that, or does that need explanation? Everybody would know that? X equals any number is a vertical line through that number. So in X equals -3, 1, 2, 3, oops, vertical line. Everybody got that? Okay. Well, when you go to Y equals, I'll make it 2, these are horizontal. Is that obvious, or does that need explanation? That's obvious. Okay. So what happens is, okay, and so that's the system. At x equals any number is a vertical line through that x number. Y equals number is a horizontal line through the y number. Always. When you add these inequalities, you are shading left or right of a vertical or up or down on a horizontal. example. In fact, I'll do the x greater than or equal to 1. All right, so if I make it graph x greater than or equal to 1, assistant, okay,
At home technical advisor needed. Well,
I've frozen. Okay. I find 1, x, that's an equal. The bar means an equal. So it's got this case in it. So I find 1, I do a vertical. Now that's x equals 1, here's 2, here's 3. So x is greater than 1 are this side. X greater than or equal to 1 shades to the right of that vertical line. I'll draw it over here. X less than or equal to 1 would shade to the left side. 1, still a vertical, but you're shading on the left. Does that make sense by itself?
What do you mean by shading?
Well, that's what I'm trying to do with this crosshatch. See, they're asking, if you go back up to the original, they're asking for a set of XY points, and their X's are greater than or equal to 1. But let's ignore, I'm just trying to break this down into pieces. So if I just want all the XY points where the X's are greater than or equal to 1, then they are on the right side of the X equal 1 line. So by shading all of the, what now?
It's to show it.
Is to show that there's an infinite number of points that have x greater than or equal to 1. This line goes forever vertical up and down, and all of the points up and down satisfy x greater than or equal to 1, and they're all solution points or answer points to this. And if you switch the greater to less than, you switch the side. This is the y-axis, this is the x-axis, this is the y-axis, and this is the x-axis. So yeah, if you make it less than or equal to 1, then you're on the, I'm sorry, I switched the wrong, my fault. This is the y-axis. This is 1, 2. So you're on the left side of 1. Does that help?
Yes, thank you.
Okay. Now here's where the course gets technical. This course is full of technical details. If you take away the or equal, they dash the vertical line. Let me show you. And I'm going to have to switch pads. Here's my yellow pad.
it's under the
Okay.
other computer.
Okay. If I wanted to graph strictly x less than 1, there's a real delay with this. I've already done it, and I got to let it catch up.
That's the issue with this.
Yeah. I've written it down, and it's the computer screen's not showing it. Why is the computer not showing it? It's showing on my iPhone screen, but it's not showing.
Well, let's try this. Stop
Okay.
share, and we should try sharing again.
Okay. All right, we're trying to fix it. It was showing on my iPhone screen, but not showing on the computer screen.
It should be connecting soon.
All right, should be connecting.
Yes.
Okay. Okay, it should have shown on my iPhone screen. Blast it.
It's not. It's having an issue with frame rate.
Okay.
So it should be
Okay. I think we're caught up. Let me draw the next. You still do the 1. Here's the y-axis. But without the or equal, points on the line don't work. So it's dashed. Here's 1, here's 2. So everybody get it? When you have the or equal, they keep the line solid, just like it's a straight equals. And then you read less than to the left or greater than to the right. But if you take off the or equal, the line can't be solid because points on the line are not less than 1. They're exactly equal to 1. So then when I have x less than 1, I'm shading to this side. And when I do x greater than 1, I'm shading to the other side, again with it dashed. Y-axis dashed. X greater than 1 would be shaded this side. Right, does that make sense? Okay. Same thing with y's. If I graph y less than or equal to 1, I keep the line solid, y-axis, here's the x-axis, here's 1, the line is solid. And less y, see here's 1, here's 2, these are bigger than 1. So you'd shade up if y was greater than or equal to 1. But with less than or equal to 1, it shades down. Y less than or equal to 1. Up here is y greater than or equal to 1. Okay. Does that make sense? So greater than on y's, greater than or above the horizontal line, less than or below. Everybody get, it'd be the same thing if we took off the or equal. You dash the horizontal line. Everybody get that? Okay, so maybe I can go back to the original problem now. And what all you got to do is put this together. Okay, they're asking for all the XY points. This vertical line reads such that the two conditions are x greater than or equal to 1, and you want your y's less than 3. So what you do, make a graph. Okay, we find x equals 1. It will be solid because it has the or equal. Here's the y. Make a solid vertical at 1. We're going to find y equal 3, but we're going to dash it because there's no or equal. So 1, 2, 3, and we dash that. So that's why you got to pay real attention to whether you got the or equal or you don't have it. Okay, when we want x is greater than or equal to 1, but also y is less than 3, I've got to be on the right side of this vertical and below 3. So can you tell it's this kind of quadrant right here? All of the points would lie bigger than 1 and below 3. Once you see it done, I personally think it's very simple. You can't do anything like this on the graphing calculator. Graphing calculator only works with formulas. So it's kind of an exercise in just simple line graphing, and you know which shaded points. And so you got two simultaneous equations on it, two simultaneous conditions. See, points up here are bigger than or equal to 1, but they're bigger than 3, not less than 3. Any questions about this?
Can I just reiterate the
Yeah.
solid is if it's greater than, less than, or equal to. And then the dashed line is greater than, less than.
That's right.
Okay, Thank you.
That is correct. Okay, we're at right about 30 minutes, which is about the limit of the size that these things will reasonably upload. Anybody want to say anything or ask anything before we close off?
Hi, yes. I just want to make sure I understand that just the practice questions are due for homework.
The practice questions are for your practice.
Yes.
They're not being taken up for a grade because I've got no way. If you write them out, you'd have to scan them in and send them to me. Then I got to grade them and scan them and send them back to you. It's overwhelming.
So
But
there's no homework assignment like due, like you're not taking up anything for homework?
the quiz tomorrow
Yes,
We'll
I
have-
understand the quiz. But,
will be taken right off the homework.
okay, all right. So I was just confused because there's something somewhere that said there's homework due, and it's just kind of confusing.
I understand it. It's hard. That's my first time through on an online class like this, and it's very hard to write all the directions out in advance.
Yeah.
And so
Okay,
yeah,
makes
but
sense. Thank you.
I have a question.
Yes.
Okay, so on the textbook, there's like little quizzes involved in it that says like due September 16th. Like, what are those?
They're nothing that I messed with or
okay.
made up.
Okay.
All of the D2L problems. See, I'm going to pre-screen them so I can cut down the size of the assignment.
Okay.
And if sometimes they go off into some strange areas I don't want to mess with.
Okay, so we just don't need to deal with those?
No, you don't need to deal with them at all. The problems I want you to do will be in D2L.
Okay.
And
Thank you.
to work it, all you got to do is like work the problem, enter an answer, go to the bottom of the page and hit submit. It'll tell you whether you're right or wrong on that problem.
Okay. Thank you.
When will the quiz be available?
Tomorrow.
Like, is there a specific time?
Probably early in the morning. I'm doing a Zoom for my pre-calc at 8 in the morning. I'm going to try to get up earlier than that and have it available before 8 in the morning. It'll be due Sunday night.
Okay. Thank you.
Yeah, I will give you a link to that. It'll be in D2L.
I just have one last question. Sorry.
Yes.
So I know that there's a Google form where we have to put in the percentage of the web assign. So what what problems are you wanting us to get the do you know what I'm talking about?
Yeah,
It was like It was like a Google form where we put the percentage. What
Right.
problems are those exactly?
Okay. I wish I had. Can I get my phone back?
It's right there. Just use it.
Okay. But I'm not on here.
Okay, let me help you.
Okay, I'm going to try to get this back so I can kind of write something down and try to explain it.
Oh, you want that way?
Yeah.
Okay, you're going to share screen.
Okay.
There I go. And then we will get back to where we were.
Okay, I'm getting back to. Okay.
It should be there eventually.
Right. Okay. I do not have the exact problem numbers in front of me, so I'm just going to make up a random example. Let's say in 1.1 off WebAssign, I had you do 1, 3, 4, 6, and 8. And in 1.2, I had you do 1, 2, 3, 4, and 6. Okay, again, you do the individual problem, enter the answer. The submit button is at the bottom of the page, and it'll tell you whether that individual problem is right. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 problems. And let's say you get this, oops, not that one, this, not that one, this. So you get 8 out of 10. you would report 8 out of 10 for 80%. Now, if you want to resubmit the ones you got wrong and get them right so that you eventually get them all right, then you can tell me 100%. See, what happens is if I make the assignment in WebAssign, it's going to base its grade on all of the problems. So if you leave off number 2, because I told you to leave off number 2, it's going to mark number 2 wrong. And I don't want to mess with that.
So to get to those problems, like specifically, is that where we go to like, I know there was instructions and it was like, go to your personal study plan and then hit practice quiz. Is that what those problems are from? Okay.
That is where the problems are. And that's what I've looked through and pre-screened.
Okay. All right. That's what I just wanted to make sure. Okay. Thank you.
Okay. Anything else? How did this little system with working the problems below the iPhone work? Can y'all read this real clear?
Yes.
Yes.
Yeah.
Okay. Well, I'll keep doing this. Like I just set this up in the last 30 minutes right before this. IT told me about it, and I needed the help of my technical assistant to do it. But it's sure a lot easier on me to be able to write normal than that dumb tablet. Is anybody else want to say anything else? We're at 37 minutes, so this is getting longer and longer to upload. I don't know if you got the email, but I am going to hold a Zoom meeting at 12 tomorrow to make up for the one I was supposed to hold at 12 today.
Thank you.
Okay, we'll be
Yeah,
working.
thank you.
All right, sure thing. We'll be holding more problems or working more problems between 1-1 and 1-2. All right, we'll end the
Awesome.
meeting.
Thanks for hosting.
Sure thing. Thank you. Appreciate y'all coming. Thank you very much, and we'll end the meeting, and I'll see if I can get this uploaded. Thank you.
Yeah, thank you, man.